Good day to you. You are welcome to our class. Our topic today is a complex number. If they say that complex number is written as Z. Is an ordered pair S comma Y. If they say that ordered pair means S has come before Y. And it's written as Z equal to X plus I Y. Where this I is called imaginary number, which is written as square root of minus 1. So this I means square root of minus 1. This S, we call it the real part, while this Y, we call it imaginary part. This I itself is called imaginary number. So in engineering, they normally use J in terms of I, because they believe I is being represented by current. So in that case, we normally write X as this, real Z, that is the real part of Z. So we write it in a short form like this, real Z. So if they say that real Z, they are talking about X. So imaginary part is Y. So we write it as Y equal to im Z. Now, what are the things we normally consider in complex number? This I is very important. So let's quickly consider operation on this I. We have said that I is square root of minus 1. In that case, we can find I square. I square will just be square root of minus 1 squared. So this square root will cancel this. Our answer is minus 1. So that means I square will be minus 1. Another important one is I cube. I cube will be I square times I. But I square here has been minus 1. Then I is I. So minus 1 times I is minus I. So we can do for more powers. Like I4 should be I square times I square. And I square is minus 1 times minus 1. Minus 1 times minus 1 is 1. So we can do for more. But what we want you to gain here is that anytime we see I square simply means minus 1. Then if you have more than I square, then you can be dealing with it like this. For instance, if you have I5 should be I square times I square times I. I square is minus 1. I square is minus 1. Our I is still high. So minus 1 times minus 1 is 1. So it remains I. That means I raised to power 5 is just I. It's simply I. So if I'm having I raised to power 99, it can become I raised to power 98 times I. We are only trying to express this in terms of square. That is why we use 98 directly. We know that 98, if you divide it by 2, we can still write it as I square. We find a way of bringing 2 out, so that this will be I square times 49. Because 49 times 2 will give me 98. Then times this I. I square is minus 1. So this is minus 1 raised to power 49 times I. But minus 1 raised to power 49 is minus 1 times I. That is minus I. So that means I raised to power 99 is minus I. Another important one on I is division. If you have 1 over I. If you have 1 over I, just rationalize, multiply both sides by I. So 1 times I is I times I is I square. And our I square is minus 1. So this should give me minus I. That means 1 over I is minus I. So we can continue dealing with that. If they now say that 1 over I cube will now be, since we know that our I cube is minus I, so we can write it like this. This is minus 1 times 1 over I. 1 over I here has given me minus I. So our answer is I. That means 1 over I cube is same thing as I. So like that. Now, complex number, as we have said, complex number, we say in rectangular coordinate. In rectangular coordinate is given as this x plus iy, as we have said before. As we have said here, the x and y, they are numbers, they are real numbers. Now, if they say that complex conjugate is changing the sign here. If it is plus, we change it to minus. If it is minus, we change it to plus. Then we put bar here. So complex conjugate of this will now be, we write it as z bar, which should be called zx minus iy. The real part first before the imaginary part. So that means if you have z to be 3 minus 2i, then the conjugate, which is z bar, will become 3 plus 2i. If you have z to be equal to 2 minus 5, 2 plus 5i, then the conjugate will be 2 minus 5i. But if you have something of this nature, z equal to, let's say, 5i minus 2. We cannot say that our answer is 5i plus 2. It's wrong, totally wrong. What you are going to do is you need to rearrange this thing. You write the real part first before the imaginary part. So we first write it like this: minus 2 plus 5i, which is the same thing as 5i minus 2. Then I cannot find the z bar of this. So the answer now is, you change the sign in between there. This is minus 2 minus 5i. So that is the conjugate of this. So this one is wrong. Another important one is operations on complex number. So we want to be dealing with addition, subtraction, multiplication, and division. So we want to be dealing with this. That's what we mean by operations on complex number. If they say that we want to add or subtract two complex numbers, let's say we have x1 plus iy1 and we have s2 plus iy2. To do this, we only need to add up the real part and we add up the imaginary part. That means it will be s1 plus s2 and then y1 plus y2. And the same thing goes to subtraction. We take the real part to real part, imaginary part to imaginary part. You cannot add the real and imaginary part together. But for multiplication, when we are giving, we need to expand. Now let's take example to buttress the point. And if it is division, we normally apply the rationalization method. That is, we multiply both sides by conjugate of denominator. That is what I explained here, complex conjugate. Now let's take example. Example 1. Let z1 be this, let z2 be this, and let z3 be this, and z4 be this. Evaluate the following: z1 plus z2. So let's take it one by one. The first one is z1 plus z2. Our z1, this is our z1 here, 3 plus 4i plus z2. This is our z2 here, minus 2 minus plus 3i. So this plus has no significance again. Now, in order to do this, you only need to pick the real part and real part. So the real part here is 3 and minus 2. So 3 minus 2 is 1 plus 4 minus, sorry, this is plus here. 4i plus 3i, that is 7i. So that's our answer. The second one says z1 minus z2. Z1, these are z1 here. Our z1 is 3 plus 4i minus, the minus will always affect, so we need to put open bracket for z2. Z2, these are z2 minus 2 plus 3i. The first thing is, let's open the bracket. This is 3 plus 4i. If you expand, it will become plus 2. Minus times minus. Minus times plus here is minus 3i. Then we bring the real part together. 3 plus 2, that is 5. Plus 4i minus 3i. You can see I'm adding the real part and imaginary part separately. 4i minus 3i will become 1i, which we can write as ordinary i. The third one, which is C, z2 bar minus 4z4. z2 bar minus 4z4. Now the first thing is z2. This is z2 here, but the bar that is there means conjugate. That is, we have to change this thing to minus. So what we have there will be minus 2 minus 3i. So this is representing z2 bar, the conjugate. The minus 4, so we need to open brackets for z4. z4, these are z4 here. 3 minus 5i. 3 minus 5i. Now if you expand, what do we have? We have minus 2 minus 3i. If you expand this one, it will become minus 12. Minus times minus here will be plus 20i. Now let's take the real part. These are the real parts. So minus 2 minus 12 will give me minus 14. Now for the high, minus 3i plus 20i will give me 17i. So that is for that. That is for C. Now for D, D is talking about multiplication, z1 times z4. So z1 times z4, that's what we are dealing with. So our z1 is 3 plus 4i times z4. Our z4 is 3 minus 5i from what I have given before. Now this is it, z1 and z4. Now let's expand it. For this, anytime you are giving multiplication, you need to do normal expansion. That is, use 3 to multiply this and use 4i to multiply this. But in this case, you need to take note that I square will give me minus 1. In this case, let's start 3 times 3, or better still, let's write it like this: 3 minus 5i plus 4 into 3 minus 5i. You know, that is how we normally expand. So 3 times 3, 9, minus 3 times 5i, 15i, plus 4i times 3, that should be 12i. Now 4i times minus 5i. Look at what we want to do. 4i times minus 5i. Let's take the number first. 4 times minus 5 is minus 20. Then I times I, that is I squared. But remember, I squared is minus 1. So what we should have there is minus 1. And this place will now become 20. Because the minus will cancel this. So in this case, let's bring the real part together. 9 plus 20, that is 29. Also the imaginary part, minus 15i plus 12i, that is minus 3i. So that's our answer. So the next one is z4 dot z2 bar. z4 dot z2 bar. Our z4 is here, 3 minus 5i. But this is our z2, minus 2 plus 3i. So the bar on it means actually it means conjugate. As you change this plus to minus, in that place we are going to have minus 2 minus 3i. So let's expand. 3 times minus 2, that is minus 6. 3 times minus 3i, that is minus 9i, minus 5i times minus 2i, that is plus 10i, and the last one we need to write so that we will not make mistake, minus 5i times minus 3i, minus 5 times, so this should give me 15i square if you multiply, but I square is minus 1. In that case, we are going to have minus 15 there. Finally, our answer is minus 6 times minus 6 minus 15, that is minus 21. And the imaginary part, minus 9i plus 10i, that is plus 1i, or we just say plus I. For f is z3 over z1. So we need to bring out z3. These are z3 minus 4i minus 3i. This is our z1 minus 4 minus 3i. 3 plus 4i is our z1. Now anytime we are giving division, this is division of complex number, you rationalize. How do you rationalize? You multiply both numerator and denominator by conjugate of this denominator, that is 3 minus 4i over 3 minus 4i. Then we now need to expand the two. Let's now expand. Minus 4 times minus 3, that is minus 12, minus 4 times minus 4i, that is plus 16i, minus 3i times this, that is minus I, and finally 3 minus 3i times minus 4i. So if you apply what I've been doing here, it should give you minus 12. This is over. If you multiply this, now this is conjugate of each other. Our answer is 9 plus 16. Anytime you are multiplying the conjugate, you don't need to do much expansion. It's just 3 times 3 plus 4 times 4. And if you still do the normal expansion, you are going to get what is here. So that at the end of the day, if you expand, that should give you minus 24. That's minus 12 minus 12. That is minus 24. 16i minus 9i, that should give you 7i. So finally, you are going to have this over 25. That's our answer. And the final one there, you are finding z3 bar over z4. z3 bar over z4. z3, these are z3. But the bar there means I should turn this thing to plus. So we are going to have minus 4 plus 3i. That is z3 bar over z4. So these are z4 here. 3 minus 5i. So this division will follow the same process by multiply both sides by the conjugate of this denominator. So that we are going to have 3 plus 5i over 3 plus 5i. Now, we now need to expand. Minus 4 times minus 3, that is minus 12. This is 12. Minus 4 times 5i, that is minus 20i. 3i times 3, that should be 9i. And finally, 3i times 5i, that is minus 15, because it will give you 15i square. And 15i square will give me, because I square is minus 1, you have minus 15. So this one, just like this, is just 9 plus 25. That is 3 times 3 plus 5 times 5. Because they are the same thing. The only difference is minus. So they are conjugate of each other. So it's very easy to multiply. Now, the real part, let's bring it together. Minus 12 minus 15, that is minus 27. Then the imaginary part, minus 20i minus this, that is minus 11i over 34. So that will be our answer. And we can decide to write it like this: minus 27 over 34 minus 11i over 34. It's still the same thing. And if you leave it like this, it's still the same thing. So that is that about complex number in rectangular coordinate. So let us now move further. Now consider complex number in polar coordinate, or we say in polar form, and that simply means in trigonometry form. That's the meaning. Now let's consider this diagram below. We know that this one is x-axis. That's why we put x there. This one is y-axis in a plane, in a two-dimensional plane. While this is slant one, which we denote as r. Now by SOHCAHTOA we know that sin theta is opposite over hypotenuse. This is opposite. This is hypotenuse. This is adjacent. Cos theta is adjacent over hypotenuse. That is why we have s over r. While tan theta is opposite over adjacent. From this place, if you make y the zero formula, we should have that y is equal to r sin theta there. S is equal to r cos theta there. While this one, we are coming there, we need these two first. So we already know that complex number in rectangular coordinate is given as s plus iy. So let's substitute these things there. So this is x, we put it there, r cos theta plus iy, these are y, r sin theta. So r is common, so let's bring it out. So we have cos theta plus I sin theta. So this is known as complex number in polar coordinate, or we say in trigonometry form. So if they say that complex number in polar coordinate or in trigonometry form, so we say that instead of using z plus iy, we say r into cos theta plus I sin theta. Then our aim is to now know what is our, because the parameters we have here now are r and theta. The question is, what is our r? How do we get our r? How do we get our theta? Now we are coming there. We can get our r from this place using Pythagoras theorem. If you make use of Pythagoras theorem, you are going to have r square equal to s square plus y square. Making r the same formula, r will be what? S square plus y square. So this is our r. The next thing is, what's our theta? We can get our theta directly from this one. If you make theta the same formula there, our theta is arc tan y over s. So that means our theta is arc tan imaginary over real. The r is square root of real part square plus imaginary part squared. Now this r itself, what do they call it? We call it absolute value. Absolute value of z. So it is written as this. So I can write my r as this, absolute of z. Absolute of z simply means square root of s squared plus y squared. Y theta, we call it argument of z, which we write as this, arg z. So if I say that theta, I simply means arg z. If I say that arg z, I simply means theta. And our arg z is arc tan y over s. So we should always put that in our mind. So what we have learned there is that z is equal to r cos theta plus I sin theta, where our r is absolute value of z, which is written as square root of s squared plus y squared, or square root of imaginary square plus real square, and our theta, which is arc z, is written as arc z. So that one is given as arc tan imaginary over real. So that is that about that. And this diagram itself, we call it an argand diagram. We call this diagram an arctan diagram. So these are the things we need whenever we are dealing with complex number in polar coordinate. Now let's take example. Let's express the following in polar form. The first one is I, 1 plus I. Now let's take it one by one. Let's say the first one is z equal to 1 plus I. All we need to do is we need to know what is our x and y. X is the real part, y is the number beside this I. So in that case, our s is, let us first locate our s and y. Our y is also 1, not this I. The number beside, and we know that the number beside this I is an imaginary one. So immediately after you have found that, you need to find your r. Immediately you need to find your r. Our r has been that square root of s square plus y square. This is 1 square plus 1 square. That is square root of 2. Secondly, you need to find your theta. Theta is arctan y over s. Those are the things we need. Arctan 1 over 1. So I will press our calculator to get this. When we press our calculator, we should get 45 degrees. In that case, our z will now be equal to, you use this formula, r into cos theta plus I sin theta. Our r is root 2 here into cos, our theta is 45 degrees plus I sin 45 degrees. So we have expressed this in terms of polar coordinates. That is our answer. If you consider the second one, z is root 3 plus I. You need to know your x, which is root 3. We need to know our y. Y is not I, but the coefficient of I. And the coefficient of I there is simply 1. Immediately we find our r, which is square root of s squared plus y squared. This is root 3 squared plus 1 squared. And that should give me root 4. And root 4 will give me 2. So we have known our r to be 2. Because root 3 squared is 3. 3 plus 1 is 4. And square root of 4 is 2. Immediately we need to know our theta. Our theta is arctan y over s. This is arctan 1 over root 3. Then from our calculator, we should get 30 degrees. So we have 30 degrees as our answer. So in this case, we cannot conclude that our answer is r into cos theta plus I sin theta. And our r is what? 2 into cos. Our theta is 30 degrees plus I sin 30 degrees. So we have expressed this in terms of polar coordinate. Now let's take the third example. Now this third example is involving minus. So anytime we are expressing in polar coordinate and it involves minus, we need to apply trigonometry very well. Now, but let me just remind you, reminder which is quadrant. If you can still remember, this is first quadrant, this is the second, this is the third, and this is the fourth quadrant. If you can still remember, in the first quadrant we have theta all through. In the second quadrant we have 180 minus theta. In the third quadrant, that is for inverse, 180 plus theta and 360 minus theta. Now let us see how this thing works in complex number. The third one is minus 1 minus I. Now let us know our x. X is minus 1, y is minus 1. So from this place, we can quickly know our r. Our r is s square, square root of s square plus y square. That is minus 1 square plus minus 1 square. So this is minus 1 square is 1. This one is also 1. So our answer there is square root of 2. Our theta is arctan y over x. This is our y is minus 1. Our x is minus 1. So this is arctan 1. So minus 1 cancel minus 1 is 1. So after 1 is what? 45 degrees. But this 45 degrees is wrong, because it cannot give us, because of this negative negative. So it's not possible it gives me 45 degrees. So how do we do that? So we need to come to the how do we proceed from this place? We need to come to the inverse quadrant. We consider the given value of x and the given value of y. Don't forget about the numbers. The x value is negative and y value is also negative. So when both are negative, we know that this is positive y, positive x, negative x, and negative x. But here we are giving negative x and negative y. So this is negative x, this is negative y. When we are dealing with a graph, in our graph sheet, we know this is negative y. This is negative. So it will fall in this third corner. So what should be there will now be 180 plus whatever answer we get. In that case, our real theta will be 180 plus 45 degrees. So anytime we are giving minus in complex number like that, I want to express in polar. So we need to apply that. So this will give you 225 degrees. So that our z is r into cos theta plus I sin theta. Our r is square root of 2 into cos 225 plus I sin 225 degrees. So this is our final answer. And the last but not the least, there we are given this 1 minus I root 3, z equal to 1 minus I root 3. Let us know our x to be 1. Our y is the coefficient of s, which is minus root 3. Minus root 3 is our y, coefficient of this I. So there's minus there, there's root 3. So it's y is minus root 3. Immediately let's know our r. So I will still be using this. R is square root of s square plus y square. That is 1 square plus minus root 3 squared. This is 1 plus minus root 3 square is just 3, which is square root of 4. And square root of 4 will give me 2. So we have known that. The next thing is our theta. Theta is arctan y over x. So what's our y? Our y is minus root 3 over our s is 1. So I will press this from, just bring the minus out. I will have this left. Let me write it here. Minus out. It remain arctan root 3. But arctan root 3 from our calculator will give me 60 degrees. So neglect the minus. So this is one we are dealing with, 60 degrees. So we now need to come to the table. Because minus is given there, we need to come to the table and check where it falls. But what is given there is that s is positive and y is negative. Forget about the number. Positive and negative, that is what we need. S is positive and y is negative. We look for where s is. You can see that this is where s is positive. This is where y is negative. So it falls in the fourth quadrant. And what we have there is 360 minus theta. So the theta we got here is 60. Forget about the minus. So in that case, our normal theta will be 3 on 360, because what we have there is 360 minus theta. It will be 360 minus theta, which is our theta is now representing 60. So our answer is 300. In that case, our z will now be r into cos theta plus I sin theta. Our r is 2 into cos 300 plus I sin 300. So that is that about that. Let's consider another example. Let's assume that you want to express z equal to 2i in polar form. So solution, z equal to 2i. we should know that our x is 0, our y is 2. Since our x is 0 and our y is 2, our r will now be square root of x squared plus y squared. This is square root of 0 squared plus 2 squared. So it's simply 2. The next thing is theta. Theta is arctan y over x. This is arctan 2 over our x is 0. This is arctan 2 over 0 simply means infinity. And arctan infinity is 90 degrees because arctan infinity means that what number will the tan give you infinity is 90 degrees. If you press your calculator, if you press tan 90, it will display error, which is this infinity. So arctan infinity is 90 degrees. So in that case, our z will be r cos theta plus I sin theta. Our r is 2, so that is 2 into cos 90 plus I sin 90 degrees. So in that case, you cannot say that okay, this is our answer. This is our answer. So you can practice this one. What is the express in polar form? Minus 2i. Express in polar form, 3 minus 3i. 3 plus I root 3. So let's try this. Another one, minus 3 plus 3i root 3. Now another example, let z1 be this, z2 be this. Evaluate the following. So I only do 2 out of it, so you do the rest. The first one says we should evaluate z1 plus 2z2, absolute value. Now let us consider this one inside, z1 plus 2z2. And our z1 is 3 minus 4i plus 2 into z2. So if you expand, this will be 3 minus 4i. If you expand this, we have minus 4 plus 10i, which will give me 3 minus 4i is minus 1. Minus 4i plus 10i will be 6i. But what we are looking for is absolute value of z plus 2z2. So it will just be absolute value of minus 6i. And absolute value is our r, which is simply square root of x squared plus y squared. So which we explained the other time. It's simply, if they say that absolute value, it simply means square root of real, no, s means real, the real square plus imaginary square. The real is 1, the imaginary is 6. So the answer is just square root of 1 square plus 6 square. So this is square root of 37. So you can do the rest too. You find this, then you find the absolute value. Finally, you find the square of it. This one too, z2 times z1. You first find z2 times z1, then you find the absolute value. Likewise this. And I'll do the last one, which is e arg z1 plus z2. Now let us first know z1 plus z2. z1 is 3 minus 4i plus z2. Our z2 is minus 2 minus 5i. So this will just be, let's remove the plus, minus 2 plus 5i. So adding it together, 3 minus 2 is 1. Minus 4i plus 5i is just I. In that case, arg z1 plus z2 is what we are looking for. It's just arg 1 plus I. And what that means, argument, we said argument simply means theta. Arg of a complex number simply means theta. And what is theta? So this is arctan y over x. This is arctan. What's our y is 1. The coefficient of this, we have been doing that. Our x is 1. So that will be arctan 1. Our arctan 1 is 45 degrees. So that's our answer. So we can consider many things under this complex number. So if we have polar form, let's consider this. Consider we have these two complex numbers. Z1 is this, and if you have Z2 to be this, we can find Z1 times Z2. That is multiplication of two complex numbers. So it's simple. We apply trigonometry. So our answer is just R1 times R2 into cos theta 1 plus theta 2 plus I sine theta 1 plus theta 2. If it is division, Z1 divided by Z2 is just R1 over R2 into cos theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So you can see when we are multiplying, we add up the angles. So let's now assume that we want to evaluate this. Let's assume that our Z1 is 3 into cos 30 plus I sine 30, and let's say Z2 is 7 into cos 60 plus I sine 60. If I want to find Z1 times Z2, I'm going to have, we multiply the numbers 3 times 7, that is 21. 21 into, according to what we have here, if it is multiplication, you add up the angles, that is 60 plus 30, and I sine, okay, this is 60, 30 plus 60, this is also 30 plus 60, this is 21 into cos 30 plus 60 is 90 plus I sine 90. It will now be simple from this place. This is 21 into cos 90 will give me 0, I sine 90 will give me 1. So what we have here is just I, because this is 0, sine 90 is 1. Our answer is 21 I. Let's assume that we want to find Z1 over Z2 is just this over this, 3 over 7. This is 3 over 7 into cos, you can see, theta 1 minus theta 2. If it is division, we subtract their angles. That is 30 minus 60 plus I sine 30 minus 60. So this is 3 over 7 into cos minus 30 plus I sine minus 30. So you should be able to finish this with your calculator. Example here. Look at an example here. If Z is R cos theta plus I sine theta, prove the following. Absolute value of Z1 is this. So it's an assignment. Go and study it. This is the solution. I will not explain, but this is the solution. I will just help you to give you the solution. This is the solution. Another example.